Welcome. This video will describe the new vector field tool axis orientation strategies for composite milling, now available in ESPRIT Release 3.9. There are two new axis orientation strategies for composite milling, vector field and vector field on drive surface. Both strategies use open chains to define the vector field, but each uses a different vector domain. This first example illustrates the vector field option. This option is available in cases of parametric parallel planes intersection with spine curve, and contour offset patterns. The vector domain is the 3D space around the model. A composite milling process has been applied to a freeform feature. This wall face is defined as the part, and the rest of the model is defined as the check. 4 open chains have been created to define the desired vector orientation at the designated places along the toolpath. The 2 vertical chains define the desired tool axis orientation at the top of the wall face, and the other 2 define the tool axis orientation around the conical face. The chains are defined as vector chains in the Composite Orientation Setup tab when the orientation strategy is set to vector field. Analysis of the resulting toolpath shows that the tool axis orientation changes to match the vector chain nearest to the tool position along the toolpath. The 3D distance from the previous and next vector chain along the toolpath defines the amount of influence that each chain has on the tool axis orientation. For example, as the tool moves toward the conical feature, notice how the vector chain starts to influence the tool axis orientation as the tool approaches, until the tool axis orientation is approximately aligned with the vector chain when the tool reaches the vector chain. Then, as the tool continues toward the next vector chain, the next vector begins to influence the tool axis orientation. At the midpoint between the 2 vector chains, the tool axis orientation is an equal blend of both vector chains. To further illustrate the influence of the vector chain on the tool axis orientation, in this example, one of the vertical chains has been moved slightly. The tool axis orientation now changes to match the new vector chain. It then changes to match the vertical vector chain as it moves closer. The next example illustrates the vector field on drive surface orientation strategy, available in the cases of project parametric and project spiral patterns. This strategy uses a drive surface to define the vector domain and the influence distance in accordance with the vector attract mode setting. First, we will see how the global attract mode affects tool axis orientation. A smashed surface was created from this concave face. Normal segments were then created near the top and bottom of this surface, and then chains were constructed between the ends of these segments and the z-axis. A freeform feature was created, designating the concave face as part and the rest of the model as check, and a composite operation is applied to the feature. Orientation strategy is set to vector field on drive surface, and the 2 chains created earlier are defined as the vector chains. The vector attraction mode is set to global. Analysis of the resulting toolpath shows that the tool axis orientation gradually changes according to the oriented chains as moving in a vector field that lies on the drive surface. This final example has a part set up similarly to the previous example, with vector chains defining desired tool axis path orientation along a drive surface. However, this time, the vector attraction mode is set to along cutting direction. Analysis of the resulting toolpath shows that the tool axis orientation gradually changes according to the oriented chains, moving along a vector field that is wrapped around the part. The attraction with the input vector is considered by the distance along the cutting direction. This vector field attraction creates a blend of the angles between the orientation vectors and the local normal of the drive surface. Thank you for watching this ESPRIT product feature video. We hope you found it informative.